Hello, good day, viewers. In this virtual class, essentially we're going to look at this integral function before us, the integrated cos raised to the power of 4x minus sine raised to the power of 4x, divide the square root of open bracket 1 plus cos 4x, close bracket, dx. Here, let's see how we can, handle this integral. Now, you recall that if we have a raised to the power 4 minus b raised to the power 4, this can be written as a raised to the power of 2, close bracket, raised to the power 2, minus b raised to the power of 2, close bracket, raised to the power of 2. And you see that what we have here is square, that should draw our mind to what we refer to as the difference of two squares. So here we can simply, this can simply be written as a square, open bracket, a square plus b square in one bracket, then in another bracket a square minus b square in another bracket. So this expression tends to be this, using difference of this way. So similarly, at the numerator of our integral function, we will express this in that manner. Okay, so we can say this is a cos square x in brackets minus sine square x in brackets raised to power 2, here raised to power 2, so that we can now express this as cos square x plus sine square x into cos square x minus sine square x. But you recall that cos square x plus sine square x is equivalent to 1. So that the whole of this expression here at the numerator becomes cos square x minus sine square x, if this is equivalent to what? From trigonometry identity. Okay? Then here we can also simplify further by saying that this expression can be written as cos square x minus, in place of sine square x, we can say, we need not bother ourselves. We should recall that cos square x minus sine square x is equal to cos 2x. Okay, that's the expression for it. Okay, if you want us to prove it further, we can as well do that. Now, if we know from identity that cos x plus x is, or cos a plus b is equal to cos a cos b minus sine a sine b. But if a is equal to b, we will essentially now have that this is cos a plus a is cos 2a is equal to cos a in that aspect will be cos square a sine a minus sine a will give us sine square a. Okay, so we are correct by saying that cos square s minus sine square s is equivalent to cos 2s. Okay, now let's look at the denominator here. Here we have 1 plus cos 4x. Now cos 4s can also be written as cos into open bracket 2x plus 2x, that is 4x. And with our expression here, we can say this is cos square 2x, cos square 2x minus sine square 2x. Okay, so that we can also say that cos square 2x minus sine square 2x we can also say is cos 2x. But here, we will go further than this. Okay, what we need to do here, we say this is cos square 2x minus. So from trigonometry identity, sine square 2x will become 1 minus cos square 2x. Okay, so that's here minus times 1, we have a minus 1. Minus times minus, we have a cos 2x. So that here will become cos square 2x plus cos square 2x minus 1. Here will become 2 cos square 2x minus 1. So we'll look at this, our denominator here. We converse with this square root. We have a 1, which is this one already, plus the expression. So cos 4 2s is equal to 2 cos square 2s minus 1. So this is 2 cos square 2x minus 1. Here, this one is off with this, and we'll be left with cos square 2x. And if we have, what we have here is the square root of 2 cos square 2x. This can also be written as the square root of 2. Now, here cos square 2x can be written as cos 2x raised to the power of these 2 times the square root means half. Okay, this will go with this, and we will be left with root 2 cos what? Cos 2x. Okay, cos 2x. So the whole of the denominator of this expression become root 2 cos 2x, and the numerator is cos 2x. So that we can now clearly see that the whole of this expression becomes integral of integral cos 2x divide root 2 cos 2x dx. Cos 2x is off with cos 2x, and we will be left with half, okay, 1 over, not half, 1 over the square root of 2 integral of 1 dx. So, and if we integrate 1, definitely our answer, our integral become 1 over the square root of 2x plus a constant c. So eventually our answer here becomes, integral is equal to x over the square root of 2 plus c. So the whole of this integral is specially arranged in this manner, okay, so that we arrive at our answer clearly. Okay, please all you help me do, help me hit this link below, and subscribe to my YouTube channel. Have a nice time. See you in my next virtual class.